So I'd like to begin by sharing a pretty scary moment that I had back in 2009. I was a recent grad of computer science at my first job. And I find myself at 3 a.m. in the morning in a deserted industrial area outside the city, alone in my car. And I left the car with a screwdriver in my hand. So how did I end up in this situation? As I said, this was my first job. I was an infrastructure developer at Waze.com, the navigation app. And for security reasons, we had to pretty promptly update the operating system version of our servers. And when I say servers, I mean 3 physical machines in a basement in a server farm outside of the city, and we figured out the time of least traffic, which for trivia fans used to be Wednesday, 3 a.m. And we met there, the entire infrastructure team, 3 developers, with screwdrivers, CD-ROMs, hard drives, emergency backups, and all the equipment that you can think of. We installed the update, and it was a very tense moment when we restarted the servers. And everything went well, and we went home and overslept. And by the way, if it wouldn't have worked, we probably had to stay all night, and traffic would have been paralyzed for a day or two, but fortunately it did. And you probably now think that I had too many time zones, because this is 2019, and why am I sharing a 2009 story? And clearly, this is a front-end conference. So you might be thinking that I got the wrong one, because what is this story relevant to front-end? And the reason that I'm sharing this story is because the extraordinary or the amazing revolution that the backend discipline overwent in the last decade gives you, front-end developers, amazing tools to develop sites with unprecedented velocity today, and I'm going to show and explore these tools. From my standpoint, the point of this session is to have your next project or part of it built with serverless tools in a way that will save you time and effort and communication overhead. So I'm going to present the tools that exist in the market and the ways to approach them, and then we'll have an open session you can approach with projects that you're building, and I'll try to give on-stage advice on what are the proper tools or ways to build them. And before I present myself, I'd like to kind of get to know you. So how many of you are front-end developers? Designers? Back-end developers? Product? Management, God forbid? Okay, so I can speak freely. Perfect. So my name is, this is actually the audience I was hoping for, front-end developers. So my name is Matan. I'm coming from a fairly back-end-ish background, infrastructure developer at Waze, then back-end developer at Yahoo, CTO, kind of full-stack job at a mobile startup called User, then start a serverless company called Binaris, and now I'm the serverless team leader at Wix.com. A little bit about my current job. Wix started as a static website generator, meaning that you drag and drop elements in an online editor, and you shape your site without any prior knowledge of web technologies. Then we moved to what we call template sites, meaning that we had templates for restaurants, hotels, car reservations, whatnot, like dozens of verticals, and you had to fill in the design and the text and the logo, but we had the backend for you. But since we couldn't cover all use cases and verticals in the world, and since some users or customers wanted to customize their sites, we moved to coded sites, meaning that you can add any arbitrary JavaScript code to your site to customize it to your needs. And what it looks like is you have a website built with Wix, and you have an editor in which you can edit all the elements, textual, graphics, whatnot. And at the bottom of the editor, you have also code, meaning that you can front-end code, for each page. You can change the elements or set custom behavior to your site. And in addition to that, and that's the serverless part, we have also backend code. So You can, and databases, sorry. So you can write backend functions that access databases and whatnot and call them from the front end in a synchronous way like any other function. And databases which are essentially easy to handle like a Google Sheet. So that's my daily job, building this backend, the backend of this product. So back to serverless. The evolution that we overwent, or the server discipline overwent, the backend discipline in the last decade, was moving all the undifferentiated heavy lifting that we used to do and that every other company in the world did before we could deploy our code to the cloud providers. And we began with physical servers, and with physical servers, we still had the screwdriver and the expertise how to install them and to purchase them, and we had to install operating system on them, and web servers for load balancing and routing, and then application servers, Tomcat, Node, whatnot, and only then reached the point in which we could write our business logic code. And in terms of time and effort, it could be easily weeks to months before a new team could write their real customer-facing code of the real product. I mean, for that, they had to handle all that stuff. And in terms of effort, I think that any number between 10% to up to 50 or 60% of the development effort, at least in the first year of the project, was dedicated to building the same thing that any other company was building. And then came the industry matured, both technically and conceptually. And we had virtual machines, meaning that we handed the physical layer of our system to the cloud provider, and we only had to do operating system, web server, application server, and before we reached the code, which is still a lot. And then about 5 years ago came containers, and with containers, you don't have to handle the operating system, no more upgrades or security patches done by us. We still had to handle application servers and our code, and then came along the DevOps discipline. We had to manage containers, schedule them, allocate containers, manage the fleet, which again took effort and was blocking for many use cases the development effort. And the latest and greatest in software development is functions. And by functions, I mean cloud functions. We handed all the undifferentiated heavy lifting beneath that to our cloud provider. And now when we want to add business logic to our backend, we simply write a piece of usually JavaScript code. Another process that happened in the last decade is that JavaScript was popularized and became the #1, the most popular language in the world. So we now write a JavaScript function, and function is the natural way, I think, for every developer to think about code and logic. There's an entry point with a given input, and you get you return a given output, or sorry, a computed output. And when you hand that code to your cloud provider, you get 2 artifacts. You get an endpoint, usually an HTTPS URL. Calling that endpoint invokes the function, and you get back the results. And you get an SLA. You get a kind of a contract that says how many functions can run in parallel, what's the latency that you're going to expect, what is the cost, but it's only data. You don't have to manipulate everything. You don't have to provision any resource. You call that endpoint, you get the answer, and you pay per request. That's it. But when I'm talking about full applications, it's not just about compute, right? There's data, and you still have to provision databases and access them. So data overwent the same process that compute went. So we had physical servers, and we had to manage them because if a database instance is going down, you lose data, so you always have to take care about replicas and think about how to overcome failures with your data. Virtual machines solved the hardware, but we still had to do all the fleet management. Managed data servers are data servers that the cloud provider gives you and you have access to, but you still have to think in terms of machines and fleets and replicas, and it's not all automated. And fortunately, in the serverless era, we now have serverless databases, which are essentially the same thing as functions. You get 2 artifacts from a cloud provider. You get an endpoint to access the data, and you get an SLA. That's it. And all your calls to data are abstracted away by a simple API call. And I think this is a very natural way for front-end developers to approach data, because what we do at the front end for local storage or accessing data from APIs is approaching an endpoint, getting data from that endpoint, perhaps writing another call to another API, another endpoint, and writing back the data. So no infrastructure there. And this means the combination of serverless compute and serverless data means that today your entire application, data and compute, can be written and expressed in code. No need to provision or build any servers. And this is an example. It's taken from a GitHub repo called the Serverless Framework with many useful examples. And even if you haven't seen this kind of YAML files before, I think it's pretty readable. It declares it's from a to-do application, lists of tasks. It provisions or it requests the cloud provider to have a table, a database table called DynamoDB, that's the database name, with this given type. The billing mode is pay per request, so you don't have to control the scaling or the instances, and you have a table name, and that's it. And when you submit that code to your cloud provider, when you commit or push it to your cloud provider, you get a URL with that database. That's it. And in terms of code, I know that it's pretty hard to read from the last rows, but I wanted to emphasize how short the function that handles, the backend function that handles the data is. Getting the data from the database, from a serverless database, and returning it to the caller using HTTP is merely 33 lines of code. And the entire to-do application is entirely written in JavaScript, and it's well under, I think, 200 lines of code. So it's easy. It's the natural way that we as front-end developers write code, and you have almost zero friction. And another issue, or another, I think, misnomer about serverless compute is that is often referred to in terms of cost and in terms of scale. And the discussion is about how fast can I scale, and can I scale to billions of requests? It's all okay. And what are the costs when you reach these limits? And there are companies that built huge news sites whose feed is a serverless function. But I think that for the most part, when you build the average project that is not facing tremendous web scale loads, I think the main points or the main benefits of building it with serverless are the maintenance, because when you upload these functions to your cloud provider, you don't have to maintain them at all. They're just there, they'll be there, and they will respond to your calls in a decade. It's about communication overhead, because if you don't need, for the most part, a server or a backend developer, you can develop rapidly on your own. And with terms of stability, it is related to maintenance. Since you don't have to upgrade anything, there's no operating system, there's only APIs, these functions will probably respond a decade from now easy. And if you build that with servers, I can safely assume that is not the case. And I'd like to show you one example that actually took me by surprise a few weeks ago. And this is a startup called Tulo. I hope that I'm pronouncing it right. And they're in the appliance rental business. They do residential buildings. They allocate a space for vacuum cleaners, for scooters, for drills, for ladders, whatnot. And the residents use their chip to borrow any of these appliances and return it on a time-sharing economy. And to make that happen, they needed the kiosk there, which was done by one developer. And they also needed other parts as well. They needed a website for customers to see the product. And they needed a mobile application to enable the rentals. And in terms of analyzing the architecture in a classic way, they had to have an API for the IoT, for the kiosk to accept rentals and returns. They probably need a BI dashboard for the backend to handle all the inventory. They need a customer-facing website, perhaps a dashboard for the users or for the other stakeholders in the company to manage users, and a mobile app. And in classic architecture, this is taken from AWS, from Amazon's cloud reference architecture. You'd have to provision quite a complicated setting of servers and databases and load balancers and whatnot. And in terms of cost, it's gonna take anywhere between hundreds to thousands of dollars, depending on what exactly you allocate. And you have to manage that. But surprisingly, they did develop that product with a serverless solution. And let's break that down. The IoT API is probably a fancy name for a few HTTP functions that respond to calls from the kiosk. The BI dashboard is only a web page, and the website and the BI dashboard for the customers are also web pages. And the mobile app, and that's the surprise that they had, is just a web page wrapped in an app. The developer used some kind of shim to connect the website in the application, had to hack through sending mobile push. It did some amazing things. Mobile push messages to connect them to the user identity in the site. But eventually, he built that actually using our product, and all the backend logic was JavaScript functions that he entered in an editor, and the product was built, that part of the product, not the kiosk, all the websites and rentals logic was built in 8 weeks. So that's, I think, pretty amazing for a pretty amazing tool to develop today. And by the way, the credit for that web page goes to Benjamin Miron. Thank him for sharing that with us. Let me go over some other use cases and other solutions that there are in the market today. And when I talk about web application, there's probably a spectrum ranging from a thin backend, which is only a few HTTP endpoints without any UI or UX at all. Then there's web component, which is something that you embed in a site, a little graphical element. It could be an iframe or even a button that you put in a site. You have what we call silly little apps. There are other names for that. I would call that like a single web page with minimal functionality, but it's a full web page. It's not an iframe, and you have to take care of SSL and all of that things. You have a website, which is a silly web app, but with probably multiple pages and a richer backend, databases, and so on. And then I think the most complex project would be a full company that has a website, but also other IT needs like schedule tasks, functions running periodically, producing reports, and so on. So let's begin with an example of a thin backend. It's something that one of the teams I was involved in actually developed for a conference. We had to register users in the booth, and we didn't have a solution for that. And the registration process usually looks like that. There is a form where you put your name and your email address, and then you get this invitation to join the site. Please activate your account using a one-time URL, a token that validates that you're the owner of that email address. Then that link links to a page where you pick your actual password, and then you get a thank you email back. And we actually implemented it with an Amazon product that is called Lambda Functions, the same idea of taking JavaScript code, handing them to the cloud. We built it with 2 functions alone, and actually our database, it was before the era of DynamoDB, was a Google Sheet. So all the other stakeholders in the company could just see the list of customers and their emails and so on. And it worked in that way. We had the email input function, which was just a post HTTP endpoint. It created a row on the Google Sheets table with the email and the name of the new user and created a token. Then when the user clicked the registration email, it marked that token as used, opened the account, and emailed the user to enter their account. And that simply worked. We never had to worry about these functions ever again. And with regards to the size, these are 2 functions, about 100 lines of code, and 2 external APIs, to the Google Sheets and to the email sending API. That's it. We have the full app. It took, I think, 2 days to write, to complete. The second example, as we grow in complexity, we have the embedded component. And For this, I'd like to show an example of an embedded sketchpad that you can put on your site and draw. This is actually driven, it's silly, but it works, by artificial intelligence. You start by drawing a cat, and artificial intelligence completes you in a way. It's a funny one. There are other examples of embedded components that you can have, meme generators or something that, or perhaps things that are more giving value. For example, real estate listings, weather, getting data from various sources. And this kind of embedded application can be done using a solution called Glitch. And where Amazon Lambda is only about code, you write JavaScript code, there's no UI elements built in. Glitch is actually built for front-end embeddable solution. So you have an online IDE in which you can edit your HTML, you can edit your CSS, and you can edit your JavaScript, which in this case accesses the external artificial intelligence API and fetches the rest of the image for you. In Glitch, there are, I think, hundreds of examples you can clone and play with. It's a super easy way to do things, but you still have to manage code. It's not just JavaScript, it's HTML and CSS as well, but you don't draw your components. And with regards to embedding, you can take that glitch part and make it a site of its own right, or embed it within any, blog. It has all the connectors to almost every web environment in existence today. Silly little app. That page that you build for your customers that produces reports or generates a PDF or does one or two tasks. Another example that we had in our team is a Slack bot that responds that the SIL web app is a backend for the Slack webhook notifications. And with that, I'd like to introduce you to another tool. It's called Google App Engine. Whereas Lambda Functions is about functions, Google App Engine thinks about your application as a full app. And you configure the endpoints in a way similar to Express. And you have to make some choices that are a bit more complicated, like picking your zone globally, where globally you want your code to be located. And in contrast to Amazon Lambda, you do have to use the CLI to work with Google Cloud for the most part. So you have to download tools locally, develop locally. It's not unlike the Glitch or Lambda. It's not a purely front-end solution that you edit within a site. And moving up in complexity, websites. I already presented Corvid, our product that enables you to easily add components to add code to web components in the site that you build. We saw the Tolu example that added a fair complex use case on top of that site. And as I presented, with Corvid, you have, unlike Glitch, which is focused on raw HTML and CSS, and you can very precisely edit the way your site looks, but you do have to handle code. With Wix, in terms of the design, you have everything in a drag-and-drop editor online. And as I go to the most complex example, or a company, what do you think the right tool for building like a website with other scheduled tasks would be? Guesses? I'm not going to say Corvid, it's okay. Okay, the answer is that you have to use kind of professional discretion, because a company website could actually be built on each and every of the tools I just presented. There are huge companies, huge websites, news sites that are built on Amazon Lambda. You can build, if your site is about embedded content, you can probably split the work to few front-end developers, build glitch frames, and build that company website from the glitch frames. If you like to use Wix, we have our editor, and you can use that and add code. And if you'd like to use Google App Engine, it's a fair solution as well. So how do you pick in this manner? I think that the first advice I can give is play with all of these solutions. I think that you can get a working example with each of these solutions within an hour or so. So familiarize yourself with the tools that are in the market. Know your team. If you're working with a team of coders, perhaps they want to approach the pure JavaScript on their command line and then probably more Lambda solution or Google App Engine. If you're working with a team that has backend developers that want to develop in Java or in Python, probably one of the cloud offerings of Lambda and Google App Engine. If you have a group, a team with designers and front-end developers working together on the same editor, perhaps Wix is the right, or Corvid is the right solution. So it's a kind of know your team, know your client. For example, if your client has an existing database on one of the clouds, if they are already on Amazon or Google, it's probably going to be a factor in your decision. So essentially, I think the lesson from this slide for me is that huge or big and complex company websites can be built using serverless solutions, and picking the right serverless solution can save you a lot of work depending on your use case. Okay, I think that's it in terms of the slides. And for now, I'd like to help you and hear about, have kind of an open session and hear about the next project that you have, either for customers or private weekend projects that you may have, and you want advice how to run them on serverless. Any volunteers? That's silent. Okay, so you can approach me if you don't want to. Anyone still want to do that on stage? Any questions? No. Okay, so you can approach me here after the session. We have a booth just by the entrance here. We do demos, and I will happily provide advice on your next project. And I'd like to thank two contributors to these slides. Yoav Abrahami for his ideas and brainstorming preparing this, and Elran Mor Yosef for the graphic design. And as I mentioned, Binyamin Meron for developing Tolu and sharing his experience with us. And thank you.